we were just discussing about this problem in the morning session. So we have first put the simplex table and we have entered all the data into it. Initially we identified the key column, then we identified the key row, and we got the key number. So since there is a negative Zj minus Cj, it indicates that there is a better possibility of solution exists over my initial solution. So I find the negatives with largest coefficient as the key column. Then I find the replacement ratio, that is nothing but the solution constant divided by my key column element, and the lowest positive. So lowest positive either 0 or lowest positive is selected as the key row for the replacement. Intersection of key column and key row, that will be my key number. So in the next iteration, what I have to do is that, so first this key row needs to be iterated first, then I need to go for the other non-key rows. Okay. So if we see how to do the key row, the key row, so the same matrix, the same data is entered over here. So as per my previous iteration, so S1 remains as it is here, but S2 will be replaced by X1 in the next iteration. So here under product mix, I can say that it will be this will be S1 and this will be X1. So the S1 has a Cj value of 0, so that remains here. But X1 will have a X1 will have a Cj value of 11 as is given in the question. So the Cj value under the Cj column X1, I have to write it as 11. Okay, I need to write it as 11. Now first the key row needs to be reduced. So the equation of the reduced key row, new variable equals corresponding element in the key row divided by the key number. That is, if you see the first value under solution constant, so solution constant is the next term. So under solution constant, okay, under solution constant, you can see the value is 32 and our key number is 4. Okay, you can see over here this is 32, so 32 divided by 4. So here it will be, I can write directly as it will be something like 32 by 4 and the value will be 8. Okay, so value will be 8. So in the next one, so 4 was the element in the previous column and 4 was the key number. So 4 by 4, so it will be 1. Okay. So the next one, so the next value is 2. Okay. So in the, you can see it is 2. So here it will be 2 by 4. Okay. It will be 2 by 4. So I can reduce it and write it as it will be 1 by 2. Under S1 it will be 0. Okay, since it is no S1 is not there in the second thing, it is 0. And this and under S2 it was previously 1, so it will be 1 by 4. Okay, so that is how. So solution constant is 32 by 4. So we have selected it like that. So under X1, okay, so under X1 it will be 4 by 4. Okay, 4 by 4. Under X2 it will be 2 by 4. Under S1 it is 0. and under S2 it is 1 by 4. So 4 is my key number. Okay, 4 is my key number and 32 is the corresponding element in the key row. So everywhere in the same order it has been solved. Okay, did you got it? Is this clear? Is this clear?
Yes, sir.
Yes, sir. Yeah. So now I'll go to non-key rows. How to reduce the non-key rows. So non-key rows, if I want to reduce, you can see this is the equation. New element equals element in the old row. Okay, element in the old row means element in the first iteration. So if under solution constant, it is 84. Okay, so 84 minus inside the bracket intersecting element of the old row. Okay, intersecting element of the old row. So intersecting element is nothing but it is 7. Okay, in the old row it is 7 and that 7 will remains constant. Okay, that 7 will remains constant. Any doubt? Okay, then throughout the next set of full iteration in the form of intersecting element of old row multiplied by corresponding element in the reduced key row, that is the present iteration. So present iteration it is 8. So here this column it will be something like this. So it will be 84 minus inside the bracket 7 into 8. Okay, 84 minus 7 into 8. 84 I have taken from the previous iteration. Okay, minus. Okay, 7 is this term, the intersecting element 7 and the reduced key element it is 8. Okay, can someone tell me what will be the value here? So that will be 28. If you solve it, you'll get it as 28. Now under x1, can somebody tell the value, how it will come? The previous value is? The previous value is 7. So it is 7 minus inside the bracket, you will have 7. 7 minus 7 into the reduced element is 1. Okay, so that equals 0. Okay, so under x2 column, similarly, it will be 6 minus inside the bracket 7 into 1 by 2. So that will be 5 by 2. Okay, that is 5 by 2. Under S1, it is 1 minus 7 into 0. So 1 minus 7 into 0. 0 is here. So it will be 1. Okay. It will be 1. Under S2, it will be 0 minus 7 into 1 by 4. It will be minus it will be minus 7 by 4. Okay, so example, everything I have solved over the example. So under solution constant, the element in the old row is 84. So 84. Okay, so I am writing here, check iteration 1. Okay, minus 7 into 8. 7 is again.
Sir, the scene is stuck, sir.
Eh?
The screen is stuck, sir. It's not.
Screen
We are
is
not able
not.
to see what. We are not able. Yes, sir. Only now we are able to see what you wrote, sir.
Oh, okay. The previous table, are you able? You didn't see?
We saw, sir.
Oh, okay, okay. Some network sometimes will have some slowness. That's why. Sorry. Okay. So iteration 1. This is key. Key column element. And 8 is, it will be present iteration. Present iteration corresponding element. I hope, is it clear? Is the things clear? Up to this, how I have solved, is it clear?
Yes, sir.
Yeah. Okay. Now calculate set J. Okay, set J of solution constant. How it will be? How it will be? It will be, tell me. Somebody can tell? Under here, under that my mouse cursor you are seeing. So what will be the value here? How will I calculate it? Set J. It will be 0 into 28 plus 0 into 28 plus 11 into 8. How much? 88. Same way, next one, it will be, yeah, 0 into 0 plus 1 into 11. Next one, 0 into 5 by 2 plus 11 into 1 by 2. Next it will be 0 into 1 plus 11 into 0. Next it will be 0 into minus 7 by 4 plus 11 into 1 by 4. So the values will be 88 here, 11 here, 11 by 2, 0 and 11 by 4. Now get me the Zj minus Cj. Eleven minus 11. 11 minus 11. 11 by 2 minus 4. Then 0 minus 0. 11 by 4 minus 0. Value will be 0. So it will be 3 by 2, 0 and 11 by 4. So that is the end of the iteration number 2. Is that clear? Now, do we need to go for next iteration? Is iteration number 3 is there?
No, sir.
Is iteration number 3 is existing? Shall we need to proceed to next iteration? Iteration number 3.
No, sir.
Why?
Because you got it in the
All are
positive
positive.
value, sir.
Yeah, either the values are Zj minus Cj are 0 or positive. So that is the end of your iteration. Okay. So all Zj minus Cj are 0 or positive. Okay, you can terminate. Now, what are the results? Where do we get the results? Okay, so that is the end. No need of calculating RR and all. So that is the end of your iteration. Okay, now what is the result? What is the result? So the results you can take it under from the solution constants. Okay, so results you can observe here. So here whatever is coming, that is your results. That is as per this problem. Okay, as per this problem, so I can say that the result is S1 equals 28, X1 equals 8, then X2, what is X2? X2 is 0 and Z max equals 88. That is, here this is showing you as your idle capacity. So this is not needed. It gives 8 components of X1. If you produce, you will get a maximum profit of 88. X2 you don't need to produce. Okay, 8 is coming over here and Z max value I am taking from here. Okay, this is going as idle capacity. Only you need to produce X1. Okay, only you need to produce X1 to get a maximum profit of 88. Clear? Is the description clear? Or do you have any doubts? Hmm? Do you have any doubts? Tell me, any step if it is not clear, please ask. Any of the step if it is not clear, you can ask. I'll just have a glimpse. So this is a given problem. We converted the inequality to equality by adding the slack variables. Since the constraint RHS is less than side, then we have find the initial solution, that is the idle capacity. By keeping our decision variables as 0, we have set the simplex table, return your the corresponding problem converted into the simplex table. Okay, Cj values from the objective function is returned. Your constraint values are returned. The idle capacity is entered into the product mix column. Corresponding Cjs is being entered. Next column is Zj. Zj is nothing but the 0 of the Cj value multiplied by the corresponding say the corresponding row and column element. Okay, then you are adding together. Okay, then you have calculated Zj minus Cj. So this is your Zj value. This is your Cj value. You done it for all the columns. You got a largest negative value. So negative value indicates for a maximization problem. Negative value indicates the presence of a better solution. So largest negative is identified as the key column. Then solution constant divided by the key column element. You got the replacement ratio. Positive is selected as the key row. The intersection of key row and key column element, we have find it as key number. Then I moved into the next iteration. Next iteration, first I reduce the key row. Okay, so it is nothing but the old element divided by the key number. The entire row is transformed. Then other non-key row is transformed using the equation. Okay, the old element in the same or the first iteration number 1 minus the intersecting element of the key column in the iteration number 1 into the element in the reduced key. Okay, so sorry, corresponding element in the present column. So that's the way I transformed it completely. I again calculated Zj. I again calculated Zj minus Cj. All are either 0 or positive. End of my iteration. Whatever which comes under product mix and the corresponding value under solution constant is your result. So result indicates S1 is my idle capacity. I can ignore it. So I have to go for X1. 8 quantities of X1 if I produce, I'll get a maximum profit of 88 rupees. So that's the end of the problem. Was that clear? Any doubt you have? We can discuss, or else I can move to the next problem.
Sir, a small question, sir.
Yeah.
Sir, you are taking from the table one, we are getting that Zj minus Cj as negative values now, sir. So you are saying that
Yes.
if negative values are present, then there might exist a better solution.
Yes.
We are moving for the next iteration, sir. But
Yes.
I can't understand one thing, like why we are taking only S1 and S1 and X in our iteration too, sir. Like
You have seen here first negative I got it. So it means that X1 has got a larger variable change is going to happen. Now X1 can replace either S1 or S2. Both it is not possible. Any one only is possible. So to determine that I have calculated, I have gone for the, I have determined the key row. Okay, key row I am determining by calculating the replacement ratio. Okay, So from the key column only, the denominator element for calculating the replacement ratio is selecting. Okay. So if it is coming here, it is modified as 6 and 2. And from here, the lowest positive value I am taking here. So here I am identifying that this corresponding change will yield a better solution. That is how I am entering x1 replacing s2. If that comes over here, if I got this as 1, then then it will be, this will be x1 and this will remains as s2 itself. Only on an one iteration, only one variable will enter into my solution space. Both it is at
So
a time, it's not possible.
so it's completely dependent upon that replacement ratio, sir. That is the lowest of the replacement ratios. That row will be acting as a key row. Then and
Yeah.
we will be checking for x1 and x2. Numerically, which is greater with a negative sign, we will take that as an issue.
No,
And
vice
based on
versa.
the key row,
Vice
we
versa.
will
Vice
replace.
versa. First, we are calculating key column. Hello.
Yes, sir. Yes, sir.
First, we are calculating key column. Then we are calculating key row. Not key row and key column. Vice versa. It is key column first, then key row.
Okay, sir. Got it. So based on that key
Okay.
column only, we are doing the next iteration, no, sir?
Yes.
Okay, sir. Got it, sir.
Clear.
Yes, sir. Clear, sir. Thank you, sir.
Yeah. Any other doubts?
Sir, one doubt, sir.
Yes, please. Carry on.
Sir, it doesn't matter, no, sir, if we first find the key row or key column. Like, why we need to follow first key column, then again key row?
How I know the denominator over here for the replacement ratio? The denominator for the replacement ratio is the element in the key column. I cannot go for randomly selecting one.
Okay, sir. Got it.
Got it?
Yes, sir. Yes.
Yeah.
Okay.
Sir, and you told that we are replacing that S2 now, sir. Could you repeat that once again? Like on what basis we are replacing with X1, sir? Only that point.
This one. This S2 how I am replacing with X1.
Yes, sir.
Yeah. So do you seen how I calculated key column?
Yes, sir. You actually did see a ZJ minus CJ. The largest of the value with a negative sign, you took it as our concern.
Yeah. So that corresponds to X1. So X1 needs to replace. X1 can replace either S1 or S2. For determining that, I have calculated the replacement ratio. Replacement ratio is calculated by dividing the solution constant with the corresponding key column element. Okay, so 84 by 7 and 32 by 4. So I calculated, I got 12 and 8. So here the lowest positive value is being taken. The lowest positive value is taken. The lowest positive value 8 corresponds to the second column, sorry, second row, where the product mix is XS2. So X1 will replace S2 in the next iteration.
So if the
Clarify?
replacement ratio values are vice versa, also it will be same thing. Instead of 12, 8, it has been 8 and 2. It had been 8 and 12. Then you would be probably taking that key number as 7, no, sir? Like if
Yes.
it was the other way around.
Yes. Then
Okay.
X1 will replace S1, not S2.
Got it, sir. Now got it, sir.
Yeah.
Thank you, sir.
Yeah, right. Anybody else? Any other doubts? Okay. If no other doubts, I'll give you the second problem. So this I already solved. So problem number 2. Please start and solve the problem. So how many slack variables?
2, sir.
2. Okay, convert that into the standard form. Okay, so I just converted that into the standard form. Converted the inequalities to equalities. Okay, what is the next step? Step number 2. What is the step number 2? You can copy the problem in a sheet of paper and solve with me. So that will be helpful for you also to understand. If I just simply run the slideshow, I can finish it off, but ultimately you will not be able to solve it. Okay, what will be the next step? Next step is to find the idle capacity. How will I find the idle capacity? By keeping my decision variables, actual decision variables in the problem as 0. What are my actual decision variables? X1 and X2. So X1 and X2, if I put it to 0, first equation I will get S1 equal 5. Next equation I will get S2 equals 12. Okay, now I am formulating the simplex table. So the first corresponding objective function values I have written. The decision variables in the problem x1, x2, s1, s2 is entered. They are the variables. These are the coefficient corresponds to variables in the objective function. Okay, S1, S2, I got the idle capacity. The corresponding values of S1, S2 is entered. RHS of the equation is entered over here. Okay, as product solution constant. So this is the product mix. This is the coefficient. Okay, so all the terms are entered. Coefficient of basic variables in the objective function. Your basic variables. Coefficient of variables in the constraint. Okay, these are the modified slack variables we have entered into our problem. This is the RHS side of the constraint. Any doubts in this? Any doubts of any of the values here? Okay. Now this is the table. Okay, this is a simple table. So here, okay, here, okay. So it is Cj minus Zj is calculating. So as I told you earlier, you can calculate anyway. Either you can calculate Cj minus Zj or Zj minus Cj. Zj minus Cj, if I am calculating, you have to take the negative with the largest value. The negative with largest coefficient comes with negative that you have to choose, not the largest one. Yeah, right. Are you solving with me? So you
Yes,
can,
sir.
yeah, so you can calculate it. So here Cj minus Zj is calculated. If you are calculating Zj minus Cj, negative values will come, vice versa, positive will come. That is the difference you have to note down. Now, which was the first key column?
X1.
Yeah. Okay. So here the greatest positive value is taken, otherwise it will be the largest negative value. That is the only difference which is going to come, however you are computing. Okay, now what is the next step? We need
Key
to
row.
calculate the replacement ratio. Yeah, good. So replacement ratio I will calculate 5 here and 1 here. So it will be 5 by 1, 12 here and 3 here. So it will be 12 by 3.
So S1 is key row.
So
S1 is key row.
S1 is key row. Okay. How S1 becomes key row?
S2, sir.
Sir, S2, sir.
Yeah. So S2 is a key row. Correct. Identify the cell with lowest value. Okay. What is the key number?
3, sir.
3. Correct. So entering variable is x1, leaving variable is s2. Key number will be, key number will be 3. Correct. Now reduce the key row first. How will you reduce the key row? So you have key number. So this will be 3 by 3, 2 by 3, 0 by 3, 1 by 3 and 12 by 3. So x2 will replace x1 and here the value will change to 6. Yeah, you can see 1, 2 by 3, 0, 1 by 3 and 4. Okay. Now reduce the non-key row. So it will be 1 minus 1 minus 1 into 1. Okay. So here it will be 1 minus 1 into 2 by 3. Here it will be 1 minus 1 into 0. Here it will be 0 minus 1 into 1 by 3. And here it will be 5 minus 1 into 4. Okay, then calculate either Cj minus Zj or Zj minus Cj again. So it will be 0 into 0 plus 6 into 1. Okay, as Zj, and so 6 minus that value if you take, that will be Cj minus Zj. Yeah. So it is 0, 1, 0, minus 2 and 24 it is coming. Now, what is the case? Now, what we should do?
We should stop it, sir.
Why?
It is 0 or greater than 0.
See, it is not Zj minus Cj. It is Cj minus Zj is calculated. Vice versa, it is calculated. If you calculate Zj minus Cj, you will get -1 over there in the second column.
Yes, sir.
Yeah.
Sir, I guess we have to go for next iteration, no, sir?
You have to go for next iteration. Correct. Which one we will select? Which is my key column now? Which will
Sir,
be my
5, sir.
Eh?
5 x2, sir. X2.
Yeah, correct. Okay, x2. Again, find the replacement ratio. Will you find the replacement ratio? 0 by 1 by 3 and 1 by 2 by 3. Sorry, that is not. 1 divided by 1 by 3 and 4 divided by 2 by 3. RHS is here, sorry. So you got 3 and 6. Now, which variable will replace in the next iteration?
S1, sir.
S1 will replace by what?
X2. X2.
Yeah, correct. And what about X1? What about X1? X1 should remain same as there, or it should be replaced with S2. What will be your opinion?
Replace with
No replacement. You have to keep X1 as it is. Don't change it, since you are getting X1 to get replaced by X2. Some problems. Okay. Here it is not happening like that. It is happening as X1 should be replaced by X2. So X1 should remain here as it is. Don't change the X1 in the third iteration. Keep X1 as it is here. Here it will get replaced by X2. You see here x2 and x1 corresponding Cj value. Now reduce the new key row. Okay. Then you reduce the non-key row. Equations are known to you. Calculate it. You can see it is shown over there. A equals B into 2 by 3 into C. 2 by 3 is here. A equals, that is shown over here. Okay, same way calculate for all. Then calculate Zj. Then calculate Zj minus Cj. Yeah, so Cj minus Zj becomes negative or 0. If you calculate Zj minus Cj, it will becomes positive or 0. Then you will get the solution. So here you can see solution. X1 will be 2, X2 will be 3, and X7 will be 27. Okay, this is how we are solving the simplex problem by using the simplex table. Is that clear? Okay, so algorithm did not evaluate an infeasible solution. Algorithm gives improving solution. Algorithm terminates when optimum value is reached.